All right, let's look at applications of percents dealing with sales prices and discounts and how we can play with those in different ways. So we're going to play both with equations and proportions with this. So first off, let's just think about a book. So a book is marked 20% off. Now, you can think of this in this example as a book. You can also think if you go clothes shopping or something and it says, hey, something is 30% off or 40% off. If it's 20% off, what percent of the original price is the sales price? Meaning, what percent are you paying? So remember that 100% is the whole thing, right? That's like all of it. So if it's 20% off, then I like to think of that as 80% on, right? Meaning we are still going to pay 80% of the original price. That's how much we are paying. So just like if something is 30% off, then you're still paying 70% of the sales price because the percent of discount and the percent that you're paying together have to give you that 100% of the entire thing. So if the original price is $40, how much is the sales price? So remember, we are playing with the 20% off, which means we are paying 80% of the original price. Now, we're going to do this problem two different ways. First is using an equation. And we're going to do that by, again, playing with the 80% of the original price is the sales price. Because 80% as a decimal is 0.8, of means to multiply, and the original price is $40, so that will equal the sales price. If I take 0.8 times 40, I get $32. So $32 is the sales price. Not too shabby. But not all of us think in an equation type. So let's also think of this as a proportion. Now, if we know that we are paying 80% of the original, remember, 80 is the sales amount and 100 is all, part to whole. Think of the ratios. So if I'm setting this up as a proportion, I know the original price is 40, so that's the whole thing. That goes in the denominator, and I'm trying to find the sales price, which goes in the numerator. I cross multiply, right? So 80 times 40 equals 100x. Divide both sides by 100, and I again end up with $32 for my sales price. So it doesn't matter which way you do it, you will get the same answer. Now let's go to number 3. If the sales price brings up $37.20, what was the original price? So we're going to do the same kind of item here. And first we're going to say, okay, 80% of the original is the sales price. Well, what do we know? 80% is 0.8. Of means to multiply. We do not know the original price, so we'll call that X, equals the sales price of $37.20. So to get the variable by itself, we're going to divide both sides by 0.8, and we get an original price of $46.50. Again, not all of us think in terms of equations. So if we go to the other side, and again, we're thinking about proportions. We know we are paying, right? 80, again, is the sales price, and 100 is the whole, they're the original. And this all comes back to 20% off means we're still paying 80% of the price. So when I think about my right ratio, the sales price is $37.20. Since the sales is in the numerator, we put X in the denominator. I cross multiply. 80X equals 3,720. Divide both sides by 80, and I again get 46.50. So it doesn't matter if you want to solve it with proportions or you want to solve it with equations. However your brain sees it, that's the way you can do it. So we do that problem two different ways. One given the original price, one given the sales price, and then two different methods. So hopefully that kind of helps playing a little bit with percents, talking about sales prices and discounts.